Yeah, I thought I could talk about influenza pandemics and the lessons that we can learn from influenza pandemics for COVID-19, because there is so much in common, and quite often we have not really reflected on what we can learn from influenza pandemics. Obviously, there are so many pandemics and epidemics in the world. This is the list from the World Health Organization. And you can see on your left-hand side the long list of pandemics and epidemics that have been occurring globally. Although I would like to pick just one, which is influenza. I won't go through, influenza, talking about the seasonal, pandemic, or zoonotic. I'll just, select some of the characteristics which I believe they share a lot with COVID-19. What is even more interesting is that if you look on the right-hand side, you can see the number of epidemic events which occurred just in 2021. And this just goes to show that epidemics are occurring all the times. We just need to be prepared to deal with outbreaks and epidemics at any given time. So Africa is not spared of the epidemics and outbreaks. You can see this map from WHO Afro. I'm sure most of you are getting the bulletin from WHO Afro on weekly basis, and it gives you a weekly summary of the events in terms of outbreaks and humanitarian crisis in Africa. And you can see that just looking at the outbreaks alone, we have got up to 104 events recorded up to last week. So clearly, this is just once again a very strong signal to say that we need to be prepared to deal with pandemics and epidemics, and if we don't, if we are not prepared to deal with epidemics, obviously we will always be caught off guard, and we won't be able to respond optimally. In terms of responding, it depends on the context, of course, because first of all, it depends whether you are dealing with a pathogen, a known pathogen, and if this pathogen has got a licensed intervention, obviously the approach will be different from a known pathogen without a licensed intervention, like chikungunya and West Nile. Looking at pathogens with licensed interventions like Ebola, because now we do have a vaccine against Ebola, things like cholera, yellow fever, and influenza, we tend to really respond quickly and be able to contain the outbreaks. But there are just outbreaks like influenza, where it's not just about a regional outbreak. You can get a pandemic, and when you have a pandemic, obviously you deal with a novel virus, and you may not necessarily have the vaccine for that. You might have things like treatment, antiviral treatment to deal with influenza, but you may not necessarily have the pandemic vaccine to deal with it. Although we have got seasonal influenza vaccines that can be used, and perhaps you can get some clinical benefit of using the seasonal influenza vaccine. In the case of unknown or emerging pathogen, like we have seen with SARS and MERS-CoV, Nipah virus, and recently with COVID-19, this can be devastating if they become pandemics, because you just don't have any intervention to use. And obviously, this is where you have to come up with a way to develop, develop and optimize intervention tools in the middle of the pandemic, as we have seen with COVID-19. Just to give you a sense of the emergency response framework on the outbreak for COVID-19, this is the slide from WHO. You can see the long list of things that can be done, from coordination to preparedness, surveillance, case management, infection prevention and control, laboratory logistics, risk communication and community engagement, continuity of essential services, extremely important. And the last one that is not coming out clearly there is the use of vaccines. And these are just tools that you can employ to contain a pandemic, not necessarily for COVID-19, but it can be applied. They can be applied to other outbreaks as well. So I mentioned that research is critical when you deal with pandemics. And it is critical for a number of reasons, because you need to be able to develop better risk modeling methods to predict the outbreaks and the pandemics. There is a need to do prevention and surveillance in many countries, especially the countries which are at risk of serious infectious diseases outbreaks. You need to identify research gaps and priorities for priority diseases at a country level, so that you are able to prepare yourself for response. And research, if it's done, it should be country-led, country-owned, but we know that you cannot work alone at this point in time. You need partnerships, you need collaborations, but you should be able to show leadership as a country when it comes to research, especially in the area of biosecurity and research infrastructure. I often say that, in fact, we need research during peacetime, and because if we don't have proper research infrastructure during peacetime, we will not be able to respond to the outbreaks. We can only respond as rapidly as possible if we have got existing research infrastructure, we have got the expertise to deal with infectious diseases. So from a science council perspective, it is important that we need to continue funding researchers so that we maintain the research infrastructure and we also maintain, the research expertise in the country. In the context of One Health, and I've seen the program that there will be a number of people dealing with this. Obviously, it is very critical to leverage on existing networks and platforms and experts from academia, industry, healthcare, veterinary care, regulatory agencies, food, safety and agriculture, and many other organizations, local and international organizations. And this is really important because most of these pandemics, they may not necessarily come, from diseases that are unique in humans. They can be zoonotic in nature, and obviously you need to work with all the sectors that are involved in infectious disease prevention and control. But the most important part is about developing new health interventions when you have got outbreaks, especially when the outbreak is about novel agent. And when you don't have diagnostic tools to detect the pathogen, if you don't have any therapeutics to use to manage the patients, if you don't have vaccines to prevent, the pathogen, you really need to develop these new health interventions in the midst of the pandemic or the outbreak. So that is really important. And this is why research is still taking center stage, even if you have got a pandemic. So research is so important, important to an extent that after the Ebola outbreak in West Africa, a number of research organizations had to come together to really prepare themselves to deal with future outbreaks and pandemics. Although nobody ever thought that we will have an outbreak or a pandemic like COVID-19, because if you look at the magnitude of COVID-19 pandemic, this has devastated all the countries, and no country could say that it was 100% prepared for this kind of a pandemic. And, you know, it's a lesson that we need to continue strengthening our preparedness to pandemics. Not to say that, you know, all the countries did not respond optimally, but most countries were caught off guard, and the response was not just adequate. So this is just to give you a sense that even from the funders' perspective, there was anticipation that there will be future outbreaks, and the funders grouped them together to prepare for these outbreaks, but still we could not deal with COVID-19. And obviously the South African Medical Research Council was part of that. So this network is called GloPID-R. GloPID-R stands for Global Research Collaboration for Infectious Disease Preparedness. The idea was that it will facilitate exchange of information if outbreak occurs, and they will be able to establish a response plan and a strategic agenda for a coordinated and a rapid research response. But as I mentioned, despite this, we were not able to really cope with the demands of COVID-19. So with this introduction, I'd just like to get to the main topic of my presentation. What can we learn from influenza? How well are we prepared to handle influenza pandemic? If, you know, in a couple of years, we are to be, influenza is going to strike us as the next pandemic. Are we able to, are we ready to prepare or prepared enough to handle influenza pandemic? And you will see from the next slides that one is never 100% ready. Even if you get signals, you will never ever be 100% ready. So influenza is attractive when it comes to pandemics because it can spread so rapidly, just like COVID-19. In fact, most respiratory infections are able to spread so quickly, and within a matter of a month, you know, the infection can actually establish itself globally as a pandemic because of the ease with which the infection can spread. So influenza virus spreads via water droplets and small particle aerosols when coughing or sneezing, very much like COVID-19 virus, SARS-CoV-2. It enters the body through nose, mouth, and eyes. So you can easily transmit this virus. If you look at the classification of influenza, you can really apply this to SARS-CoV-2 virus because it is an RNA virus. Forget about the family and all that. But the most important thing is that you have got many types, and these types are found in men and animals. So the most important one is actually type A. because this is the one that is actually a culprit when it comes to pandemics. And maybe just before I leave this slide, just to say that in most formulations, in fact, all formulations of influenza vaccines, you'll find that they are trivalent vaccines, and they will have, maybe two types of type A influenza strains and one type of the other strains. So that is a way of just ensuring that you get diversity of strains in the vaccine. But I guess the message of this is that influenza, like SARS-CoV-2, it can be zoonotic and is found in animals. It has been able to adapt in men and is responsible for outbreaks, seasonal outbreaks, and also pandemics. And then the other thing that I thought maybe I can just share with the audience with influenza virus, and this is not just unique to influenza. Actually, it applies to many viruses. Is the fact that most viruses we don't really have issues naming them according to where they have been isolated, the geographic origin of the virus. Obviously, more and more, because of the mixing of science and politics, this can create geopolitical tensions, as we have seen with SARS-CoV-2. But there's nothing wrong. And this has been the way viruses were named for many years. And I just hope that what we are learning now with new viruses like SARS-CoV-2 will not really become an issue to other viruses. So this is how influenza strains are named. So looking at the key medical aspects of influenza, it is highly infectious, highly contagious, as I mentioned. It can cause acute infection of the respiratory tract, the upper and the lower respiratory tract. It can cause repeat infections due to viral mutations. It can easily be transmitted, as I've mentioned, and the incubation period is relatively short. So because of the short incubation period, this is part of the reason it can spread globally within short space of time. Unlike SARS-CoV-2, influenza is a segmented virus. Actually, it's got 8 RNA segments. And these segments allow the virus to really undergo mutations very easily. And the mutations are different because we have got what we call antigenic drift and antigenic shift. So antigenic drift basically is when you get mutations within a segment, and this will result in minor variations of the antigens that are affected. But when you get a swapping of the RNA segments, because they are segmented, you can get major variations, and this could result in antigenic shift, where you now have a new or a novel virus that can really cause pandemics. So these mutations are frequent with influenza A, as I've shown you that influenza A can be found in men and animals. They are less so for type B and very, very seldom for type C. And the mutations allows the virus to escape immunity. So this phenomenon of vaccine escape mutants that we are seeing with SARS-CoV-2 is not new. It does happen with the influenza virus. And most of the time, the mutations involve the external antigens, hemagglutinin and neuraminidase. And the reason for this is because these are the 2 proteins that are important for establishing infection. And just like SARS-CoV-2, when you have got spike proteins, for influenza, hemagglutinin and neuraminidase, extremely important for penetrating into our cells. So when you get changes in these antigens, obviously that can escape pre-existing immunity. So the difference between epidemics and pandemics, I don't want to take too much time on this because I'm talking to the academics. Just to say that for epidemics, when it comes to influenza, they really create a situation where every year is influenza year. As you all know, that we have influenza season every year. And when it comes to pandemics, we know that they can occur every few decades. Unfortunately, one cannot predict 100% at what intervals this will occur. But they can occur every few decades. And when they occur, because they are pandemics, it will be worldwide, and quite often is because of the antigenic shift due to the swapping of the RNA segments, what we can also call it genetic reassortment. Or it could be due to direct transmission of an animal virus, quite often an avian virus to humans. So the consequence is that the appearance of a novel virus will then spread quickly in the population because there's no immunity. The new virus will be highly pathogenic, and pandemics can occur within a short space of time, 4 to 6 weeks. And as I mentioned, this is quite frequent with influenza A. And the reason for this is because you find it in both men and animals. So this just is a list of the previous pandemics with influenza. The ones that have been fully documented are the last 4, the Spanish flu, Asian flu, and the Hong Kong flu. And I think a lot has been documented on these pandemics. We know that in 2009, there was a threat of another pandemic, the H1N1 or the swine flu. Unfortunately, it was not as devastating as the other pandemics, like the Spanish flu, Asian flu, and Hong Kong flu. So we know that in terms of mortality, these pandemics were quite devastating. And you look at the number of people who perished during the pandemics. For the Spanish flu, the estimate is up to 100 million. For the Asian flu, approximately 1 million. And for the Hong Kong flu, again, about 1 million. So clearly, the pandemics, if they occur, they can be devastating, and they can result in excess mortality globally. What do we know about the H1N1 swine flu pandemic? And I've included this slide because there is a lot of similarity with SARS-CoV-2, the way SARS-CoV-2 established itself as a pandemic disease. The first report for H1N1 was in April, 12 April, which year was it? 2009. And this outbreak occurred in Mexico. It was reported to WHO, and around 15 to 17 April, then there were 2 cases in the US, California. And later it was established that actually this virus is H1N1, and it was given this strange name. 23 April, the virus was confirmed in several patients in Mexico, and WHO declared a public health event of international concern to this virus on the 24th April. And there were a number of phases, obviously, but it was declared a pandemic in June 11 because it was able to spread to more than one WHO region. Within 9 weeks, all WHO regions were reporting cases of H1N1. And we know that in South Africa, the first case was on the 18th June 2009. This is when we had the first case of H1N1. So a number of countries were affected. And as you can see, with H1N1, it took hardly 4 to 9 weeks for this to establish itself to become a pandemic. So clearly the message here is that if influenza strikes us as a pandemic, it will really spread across the world within a short space of time. And I hope this is not going to happen because we are still, battling to contain COVID-19. And even if we contain COVID-19 in the next couple of months, the legacy of COVID-19 will be with us for years to come. So I really hope that we're not going to experience another pandemic very soon. But just to give you a sense of what happened in South Africa, and I think this slide was from Barry Shook, if I'm not wrong. So South Africa was one of the most deadly, the Spanish flu was one of the most deadly pandemics worldwide. And South Africa, South Africa was the 5th hardest hit country in the world. The victims were around 20 to 40 years of age. And the estimate is that around 500,000 people died from this in South Africa. And you can see that over 60% actually died in the Cape. So for some other reasons, and maybe we don't know why, and it's something that is worth exploring and investigating. It looks like, the Cape seems to be quite vulnerable and susceptible to pandemics. And maybe I'm wrong because, I'm just basing my assumption on 1 or 2 pandemics. But the bottom line is that the Spanish flu pandemic overwhelmed the ability of the authorities to dispose of the corpses, and it paralyzed the healthcare system. And we can see with the healthcare system today, with the COVID-19, that it was stretched. And part of the reason is because we always think that we are prepared, but we are not prepared enough. So what are the lessons then that can be learned from influenza? I think the most key lesson here is unpredictability, because these outbreaks, as I mentioned, they occur unpredictably. And the other thing is that you should never ever think that even if you deal with a pathogen that you know, you can actually predict the seasonality of the pandemics. There was no seasonality in the previous pandemics. Even if, influenza occurs quite frequently during the cooler months of the year. There were great variations in mortality, severity of illness, and pattern of illness, and obviously the age distribution as well. And it's exactly what we see with COVID-19. There was always a rapid surge in the number of cases over a brief period of time, often measured in weeks. So the 2 waves that we have seen with SARS-CoV-2 in South Africa, I think one can say that the 2 waves speak to this, rapid surge of the number of cases. Pandemics tend to occur in waves with a duration of 6 to 8 weeks, and subsequent waves may be more or less severe, and you cannot predict again whether the next wave will be severe or not severe. So maybe just ending the talk, I just thought I can come back to the issue of the avian influenza, because most influenza pandemics originated from the avian virus. You can see from this slide that a number of avian influenza outbreaks occurred, and in fact, if you look at the last one, which was around 2006, 2007, this was a strong signal that most likely it might create a pandemic. Fortunately, it did not create a pandemic, but most people thought that most likely the H5N1 that was circulating around 2006, 2007 would be the cause of the next pandemic. So we survived it, but obviously we don't know whether we will not have influenza pandemic. So in 2007, the World Health Organization was very, very concerned, and there were so many signals and warnings to countries. And this is just some of the things that the World Health Organization had to communicate to the countries, because the WHO was very concerned. And as I said, in fact, the thinking was that the next pandemic was around the corner. So according to WHO, they really want all the countries that every country must be prepared for a possible influenza pandemic. And as I say, obviously this was in 2007. And the reason for this is because influenza pandemics are recurring events. The world may be on the brink of another pandemic. We survived this, of course. But as I said, we don't know if we're not going to experience a pandemic in the near future. All countries will be affected if there is influenza pandemic. There will be widespread illness. The medical supplies will be inadequate. We have seen this with COVID-19. There will be a large number of people dying. The estimate was that at least 2 million people will die. And I think this is also a lesson that we can apply for COVID-19. There will be economic and social disruption, and we have seen this with COVID-19. And the bottom line is that every country must be prepared. And as I said, unfortunately, you will never be prepared enough. So if we had influenza pandemic then, what would be the possible interventions that we would employ to fight the pandemic? Non-pharmaceutical interventions were on top of the list. And these non-pharmaceutical interventions is exactly the same package that we are using for COVID-19. I'm not going to go through the list, but you can see that is exactly the same package that we are using for COVID-19. And obviously for influenza, because we do have antivirals, there was a huge discussion about stockpiling of antivirals, especially Tamiflu and Relenza. Obviously, you can't do this if you're dealing with a novel pathogen, because you still have to research the antiviral that is effective. And there was a talk about developing pandemic vaccines, and the manufacturing part was actually dominating the discussion because everybody was edgy about scalability of manufacturing. If you have got a pandemic, of course, you need to develop large quantities of the vaccines, and the capacity was not enough, and the capacity is still not enough today. So clearly, this is the lesson that we should have learned at that time, and we increased the capacity for vaccine production and manufacturing for other diseases. So why vaccinate against influenza? Because vaccination represents first-line intervention. If you can't prevent, obviously you have to deal with the patients who become ill from infection. The vaccines are regarded as the most important medical intervention for preventing influenza and reducing its health consequences. And we know that it doesn't apply to influenza only. It applies to most infectious diseases. Vaccines are the primary weapons against annual epidemics. We know this, and they've shown proven efficacy in reducing morbidity, mortality, and associated respiratory diseases. The efficacy is around 70 to 90%, although most people will say that efficacy can be less in some cases. However, if you are vaccinated, you might enjoy the clinical efficacy of the vaccine because the clinical effectiveness of the vaccination tends to be even higher. And we know that cost benefits of vaccinations are well established, and not just for influenza, but for many other infectious diseases. So vaccination will always be a cornerstone to control infectious diseases. So as I mentioned, that there were challenges of scaling up vaccine production at that time, because if you look at how the seasonal influenza vaccines are produced, you need at least 6 months. Fortunately, we have got a technology that we can apply to produce influenza vaccines. But if you have got a pandemic, it means you have to adapt this because you need to adapt the technology with pandemic strains that will be circulating at that time. But the message here is that vaccines will not be available for most countries if we have influenza pandemic because of the production issues. We need to increase pandemic vaccine manufacturing capacity, not just for influenza, but thinking about other future pandemics. We need to ensure protection as early as possible if there is a pandemic. So in conclusion, Chairperson, I just want to say that the take-home message from the previous influenza pandemics is the fact that if you have got a pandemic, this usually involves a novel virus. And a virus does have increased transmissibility. And we have seen with SARS-CoV-2, not just the original prototype, SARS-CoV-2, but also the new variants that we are dealing with. You can have increased virulence. You can have an age shift in terms of the population, the age groups that are affected. If you apply this to SARS-CoV-2 in South Africa, between the first wave and the second wave, we have seen the age shift in the second wave, that more younger people were affected compared to the first wave. There are always novel risk factors to transmit the virus, and there is no seasonality. We often talked about SARS-CoV-2, for example, being more common, more pronounced during winter period, but we have seen with the second wave in South Africa that it can strike any minute. So never ever think that you can link the pandemic to seasonality. You do get multiple waves, and as I mentioned, it could be that subsequent waves are even more severe, and one should not bank on the fact that if you have got a first wave, then the second wave will be less severe. And the virus will adapt in the human population. So obviously with influenza, it will, adapt and it becomes, seasonal influenza virus. But we have seen with SARS-CoV-2 that is continuously adapting as now we're dealing with new variants. So I guess the message here, Chairperson, is that there is a lot that we can learn from influenza pandemics. And in fact, if we took the signals very seriously of possible influenza pandemic, we should have been more prepared, for COVID-19. Unfortunately, this in practice is not always the case. I will stop here, and I'm happy to take questions. Thank you very much.